So my partner and I love to play this game. We'll take turns trying to out-cheese each other by playing some of the greatest yet soppiest love songs ever made. So for example, I'll play a little in sync. She'll one-up me with Chicago. I'll parry with Celine Dion, but then she ends it all with a fatal blow by Michael Bolton, because nobody does cheese better than Bolton. But you know what the craziest part of all of this is? And no, it's not the fact that I still have in sync in my music library. It's that I still remember the words to songs I have not listened to in decades. Yet the lyrics are still in there, in my brain, as crisp and clear as the day I used to sing them into my hairbrush as a skinny, angsty little tween. Well, this is precisely the science that award-winning biology educator Glenn Wolkenfeld leverages to teach students biology and biochemistry. That's right, science music videos, they're a thing. In today's interview, I dig into the science of memory with Glenn and how song lyrics can be used as a way to study for your next science exam. Okay, Glenn, you've got to tell me, how did you come up with the genius idea to blend science and music?
You know, it was a very natural thing for me. I've been playing guitar since I've been 14, 13 years old. I started teaching in my mid-20s, and it was literally a case where the muses came and inspired me, because on my second day ever in a classroom, I was leading my students in singing a song about the parts of cells. And that was sort of a wonderful experience. My first job was at an alternative school. It was tough to get the kids engaged, and music wound up being a wonderful way that I could really reach out to kids, have them connect with the content, have them interact with it in a really fun way. And so that became a part of my teaching repertoire that I've done ever since, which at this point has been for a really long time.
That's great. So tell me, why do we remember song lyrics for decades, but forget what we learn in a biology lecture within days?
I think a lot of it has to do with interactivity and emotional impact. You know, if you're a good student in that biology lecture, you're going to really be focused. You're going to be taking notes. You're going to be actually reviewing your notes as you're listening to your professor or your teacher. You're going to make it a very interactive experience, but a lot of students don't spontaneously do that. On the other hand, if your teacher winds up coming into the room with their guitar, all of a sudden it's like, wow, something's happening. And that's generating a whole level of feelings that you wouldn't otherwise have. And, you know, emotionality is one key to remembering things. Things that are unexpected are also a key to remembering things. And, you know, finally, when you're singing a song, your whole body is involved. You're activating parts of your brain that you excuse me, wouldn't otherwise use. And so all of that comes together to create a much more memorable experience than what happens just if you're passively listening to something.
Yeah.
So I think that's really the key to it.
That's key. That's the memorable aspect of a song.
Mm-hmm.
Okay, well, I do feel like there could be a tendency in using song lyrics as a memory device to lean on rote memorization without much depth of understanding. So how do you address this with your students so that they aren't just parrot fashion learning the concepts you're teaching, but actually understanding the science?
Yeah. So music is one of many, many parts of my, you know, palette of teaching tools. So if you think about a song like, or if you think about a unit, like for example, cellular respiration, that's a unit where I have a song about glycolysis, I have a song about the Krebs cycle, I have a song about the electron transport chain. Well, think about what other students, what else students are doing. Students are doing things like labs where they're using a device called a respirometer to measure oxygen consumption. They're doing labs with enzymes where they're seeing enzymes catalyze reactions, and they're measuring some of the temperature changes that are associated with that. They're looking at diagrams related to the electron transport chain, and a big part of my teaching method, and a lot of that has been something that I poured into my learn-biology.com website, is interaction with the material. So students are labeling the parts of diagrams relating to the electron transport chain or the Krebs cycle. So if you put the music in context, then it yet becomes another way that you can deepen the learning, as opposed to it just being a thing in and of itself. But I also do want to say, rote memorization kind of gets a little bit of a bad rap in education these days. We're very, very focused on inquiry learning, which is wonderful. We're very, very focused on science practices, which are also wonderful. But I think that one of the keys to remembering things is actually putting in the brain power to be able to explain processes. So if my electron transport chain or glycolysis song helps students go from the beginning of the process to an end, I think that that's yet just another tool that's helping students actually remember things at a very high level as opposed to at a meaningless and decontextualized level.
Right. So it's speaking to the need for multiple modalities in teaching, where your brain has several hooks. You mentioned, the practical aspect, the rote memorization aspect.
Yeah, I think meaning is such an important part of it. One of the reasons why I love teaching biology is that biology is a very story-driven discipline in a lot of ways. You think about the processes, you think about what happens when you eat something, right? There's a beginning, there's a middle, there's an end. You think about what happens with something like cell division. There's a beginning, there's a middle, and an end. So if you can help students understand the context for that, or if you're learning it on your own, if you can think about the context, then memorizing becomes that much easier and more meaningful.
Yeah. Okay, so there may be a danger in using song to memorize science content to spend too much time on creating the song or lyrics without getting to the learning part. So how do you balance out time spent versus benefit?
Yeah, I'm not actually one of those teachers who has as an assignment having their students create songs. I teach my students some memory tricks. I actually, like Brainscape, have my students do a lot of kind of repetition-based learning and flashcards that are on my own website. Writing a good song really takes a huge amount of time. So I'm actually a little bit skeptical about the value of teachers doing too much of that. I mean, I'm an AP biology teacher, so I could imagine an assignment where after the AP bio exam, you would have students create a video that might incorporate music or things like that. But I actually think there would be a danger in doing too much of that with your students. On the other hand, my investment of time has been something that I've been able to leverage over years and years and years. I write these songs and then I get to use them again and again. So for me, it's been a fantastic way to create a memorable learning experience that I could use year after year with my students. And then on top of that, share with hundreds of thousands of other students through my YouTube channel and through my website. So really no downside from the teacher's point of view doing it, but I would want to caution other teachers about having that be a big thing that they would have them do. Teach kids how to memorize, that's fantastic. Writing songs, that's a big time commitment.
Yeah, and not everyone has the gift.
Yeah, that's true.
All right, so what aspects of the sciences do you find songs and lyrics to work the best with as memory devices?
Yeah, I think one of the things that writers are encouraged to do is to write about what they know. So for me, I know biology. I've been teaching it since my early 20s. And, it's a deep part of what I think about every day. So that's been the subject that I've written songs about for the most part. I have a couple of songs about other areas. Biology, as I mentioned a little while ago, is great because it's almost like there are implicit narratives everywhere. You think about like my cell division song, it's called Mitosis. Cells start dividing, they have to duplicate their chromosomes and the chromosomes have to move to certain regions of the cell and then they have to be pulled apart. That's a story right there. So, good songs, I think often, not always, but good songs often are very story driven. So a lot of my stuff is like that. But then at the same time, lesson plans are also stories, right? You have an objective, you come in, you teach the lesson, you wrap up at the end. And so some of my songs are actually more like interactive lectures where I'm sort of telling the story of the lesson in a very compressed time frame. And one of the frequent comments that I get on my YouTube channel is that like, wow, you just did that whole 45-minute lecture in 4 minutes. And that's about lyrical density and about really thinking through so that you're talking about the content. But for me, the best stuff has been stuff that that tells a great story of a biological process, and those have been I think some of my most popular songs as well. Though I'm interested in other things. Like, for example, I haven't released this on YouTube yet, but I have a song that I recently wrote with a friend about the evolution of stars. It's called Supernova. And so
Oh, wonderful.
maybe you'll see that on YouTube sometime soon.
Ah, that's one of my favorite science stories.
It's an amazing, it's an amazing story. Yeah.
Yeah, how we're made from stardust.
You know, it's funny, but I was exactly going to say that. You know, I'm constantly telling students that, you know, if you look at your hand, the carbon atoms, the hydrogen atoms, the oxygen atoms, those were all cooked up. You know, those carbon atoms might be, well, the hydrogen atoms are 14 billion years old. You know, they go right back to the Big Bang. And then, you know, because of stellar evolution, some of those other atoms are, you know, more recent, which means 4 billion years old or something like that. But that's a pretty astounding thing for any student or any human being to think about.
Yeah. Neil deGrasse Tyson. Well, I don't know if it was him or somebody who remixed his voice, but in one of his lectures where he's talking about how we are made from stardust in the highest exalted way, somebody took his speech and auto-tuned it and created this really amazing song. So definitely worth checking out, and I look forward to seeing what you do.
Well, if I can be compared in the same sentence to Neil deGrasse Tyson, I'm feeling like I've certainly had a successful day. So
yeah, you're doing something right. Okay, so it seems like songs can be a useful way to help memorize basic science knowledge, but is this something that could be useful for more advanced science students like pre-meds or med students even?
Yeah, I think so, and I think I've accomplished that with some of the songs that I've put out to the world. So, you know, I have a song about DNA replication, for example, that, you know, talks about helicase and DNA polymerase and ligase and most of the enzymes that are involved in that process. I think that I probably haven't written songs that are at like the graduate level just because I don't teach at that level, but you know, many of my songs have actually been at the like introductory college level, AP biology level, and they really hit some extremely complicated processes, like for example, photosynthesis extremely well, or like the structure of membrane. So yeah, I think you can do it pretty much at any level. You know, the hard thing is always doing stuff that really meets the needs of your audience. So, you know, a lot of my songs are actually too high level for middle school kids or for elementary school kids. But, you know, college AP biology is really the sweet spot. And I think that anybody who had the ear for it, the voice for it, and the musical talent could easily do it at the level, at whatever level they wanted to, you know, medical school, PhD in biology, you know, whatever you're interested in doing.
Yeah, I think that if there's a concept or something you need to memorize that you just can't get into your skull and you have like a pinch of musical talent, it might be worth coming up with a ditty to help you remember, you know, that series of information.
You know, and you know, it's funny, this relates back to an earlier question. I think that for the motivated student who's really trying to encode significant amounts of material into their memory, taking the effort to rhyme it is actually a really great idea, because it's the effort that's involved in organizing the material, telling the story, finding what rhymes. That's what helps you get that into long-term memory. And then of course, there's the recitation. So if it makes it easier for you to spit back whatever concept it is that you're trying to memorize, and if rhyme helps you do that, then by all means do that. And if you can make that into a song, it's even better.
Yeah. Okay, so what are some of your other best study tips for preparing for major tests and exams?
I think a lot of what I do and a lot of what Brainscape does is really on the same page. In other words, I'm a huge believer in active learning and in retrieval practice. So I think that as people are studying, the main thing is not to be passive. It's very easy to tell you about the worst things to do. The worst things to do is to reread your textbook or even to reread your lecture notes. The best thing to do is to recite what's in the textbook. And then of course, going through the process of creating either physical flashcards or electronic flashcards, forcing yourself to respond to questions. That's really the number one thing to do. So like, for example, I often tell my own students who are preparing for the AP biology exam that they should see those prompts as almost like cues for a little dialogue. And their job is to teach themselves how to respond to that dialogue in a fluid way. Because if they can do that fluently, that means that they understand the material pretty well. I teach my kids something that's called the 3-second rule, and I don't know if this has been verified by cognitive science, but if you're working, for example, a flashcard or working with a course outline, and you look at a term and you can't say what that term means, if you can't explain it within about 3 seconds, it means you don't know it. So if you're working with flashcards, take that flashcard and put it back on the bottom of the stack. If you're working on Brainscape, do whatever you do. That means that you need more practice on that card. I've got a need more practice button in my system. So just be strict with yourself and make sure that you truly know the material. Working towards mastery is what many students don't do. Many students will reread their notes and they'll feel confident based on what they've read. And that really can lull you into overconfidence. And then when you have to recall things on the test, it can really be a bad feeling.
Yeah, it's the difference between recognizing content and actually remembering it and having it, firmly planted in your brain.
Absolutely. It's very easy to be familiar with content and to feel like you know it. So you're reading along in the textbook and it's like, oh yeah, I know that. That seems like it makes sense. But then if you actually close the textbook and ask yourself a question, and I'll use a biology example, which would be something like, explain what happens when a cell responds to a protein hormone. And if you can start to say, well, that protein hormone is going to bind to the receptor is going to probably internally change shape, it's going to interact with some molecules just on the other side of the membrane, that's going to set off a cascade of other interactions inside the cytoplasm. If you can't do that with specificity, you don't know it. And then you need to go back and learn it well. Yeah.
Don't lie to yourself.
Yeah, it's very easy. It's very easy to lull yourself into overconfidence.
Okay, so aside from your science music videos, which are brilliant, by the way, what other supplemental resources do you offer through your website, learn-biology.com?
Yeah, thank you. And thank you for remembering the dash. It's a very important part of the name. So learn-biology.com is an entire interactive curriculum that I wrote for high school students at the AP level, which means that it also works for students in an introductory biology class at the college level. It consists of tutorials that teach about every concept in the curriculum, and that mostly involves short videos or short bits of text that are followed by massive amounts of interactions. So what do I mean by interaction? We have interactive diagrams where you have to drag labels onto parts of diagrams and you get immediate feedback. We have interactive multiple choice questions where if you click the right answer, you get some praise, but if you click a wrong answer, you get some feedback with a hint, and then it acts like a flashcard. So that card with the question will go to the bottom of the stack, and you won't get out of that study set until you've demonstrated mastery on all of that. So I mentioned diagrams, multiple choice. We also have flashcards. We have a kind of interaction that's like the game Hangman, where you have to type in the letters. But again, it's much along the lines of what Brainscape does so brilliantly, which is it forces students to interact with the material in a way that leads them to mastery. We're also really set up for teachers to use that with their students. So we have tools that let teachers track student performance. We have student learning guides. These are handouts that teachers can assign to their students so that their students can not only do the work on the flashcards, but they can also do written work, which of course is a very important part in preparing for exams in the AP biology level or almost any course. So if you're looking for, a full, fleshed out, completely curated AP college biology curriculum, that's what learn-biology.com is. And if I can just say another thing about it, we're also in the process of expanding into some other sections. So I don't mean sections, I mean other topic areas. So like, for example, what we have in the works is an AP chemistry curriculum that'll also be useful at the college level. We're developing a 9th grade biology curriculum for students who aren't at the AP curriculum. And we're starting to sketch together an AP environmental science class as well. So if you're looking for interactivity in the science space, that's learn-biology.com is a great place to go.
Oh, fantastic. Well, Glenn, thank you so much for talking to me today. Really appreciate all your inputs, and hopefully our students watching this feel a lot more confident about their studying for biology and their other science subjects.
It's been a pleasure. Thank you very much. I really appreciate this opportunity to get to talk to you.
Awesome. So if you're a student of any science subject and at any level, be it high school or university, and you find that the black and white textbook just isn't cutting it, look outside of traditional study media and discover YouTube stars like Glenn Wolkenfeld, who are finding creative ways like rhyming lyrics, graphics, animation, and music to bring science to life. You should also head on over to brainscape.com, where you'll discover thousands of already made flashcard collections on the full spectrum of science subjects. Well, these are an excellent study tool to help you memorize the fundamental concepts you need to know to do well in exams. Also, because we use adaptive learning techniques like spaced repetition, Brainscape's flashcards can empower you to learn twice as fast, and that's a fact. So grab these learning tools at your disposal and rise to the next challenge that science sets for you.